Okay, so this is scenario 3, hypothesis test for paired t-test. So we're running a hypothesis test for a paired t-test. And this was an AP question, and investigators at the U.S. Department of Agriculture wish to compare the methods of determining the level of E. coli bacteria contamination in beef. Two different methods, A and B, of determining the level of contamination were used to each of 10 randomly selected specimens of a certain type of beef. The data obtained in millimicrobes per liter of ground beef for each of the methods are shown in the table below. Is there a significant difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef? Provide a statistical justification to support your answer. So we have, first off, they want us to run a hypothesis test, and they're telling us, is there a significant difference in the mean amount? So they're looking for a difference. So because they're looking for a difference, this is going to be my key to my alternative hypothesis. So first off, it seems a little bit weird, but each piece of beef, so we have 10 pieces of beef, and each piece was tested 10 times. Twice. Each piece of beef was tested twice. Once with method A of detecting E. coli, once was method B. And this tells us about their detection success. So about the amount of E. coli they detected. So if there was no difference, it would be equal to 0. If there is a difference, it's not equal to 0. They did not ask for direction. Now, because they went A first and B second, first off, I'll put this into L1, and I'll put this in L2, and I'm just going to go A minus B, because that's the order they presented it. So let mu D equal the true population mean difference in detection methods for E. coli, A minus B. As you know, conditions, even though I list them, are assumed for our course. So you can just write assume. But once I've done that, I need to go ahead and write my equation. And my equation for the t statistic happens to be t equals x bar d minus mu d over sd divided by the square root of n. Now, please remember, the reason this is a t statistic instead of a z statistic, because the z would look like this, x minus mu standard deviation of the population divided by square root of n. It's because to use a z, we have to know this value, the standard deviation of the population. They did not tell me anywhere in this scenario the standard deviation of the population. So, and they actually didn't tell me the standard deviation of the sample, but we have a list of sample values, so we can use the calculator to calculate the standard deviation of the sample. So this is why we're using a t, because we're going to have to use the standard deviation of the sample as opposed to the standard deviation of the population. So this forces us to use a t in this situation. So this is our equation, x bar d minus mu d, sd divided by the square root of n. So we need to make a list of our inputs, so mu d, and we happen to know that because it's a paired test, so the difference, we're expecting it to be 0. X bar d, we don't know. SD, we don't know. Now we happen to know n because we have 10 pairs of data. Yeah, we have 20 data readings, but that's because each one was tested twice. We actually have 10 pairs, so our sample size is the number of pairs, which is 10. So to calculate x bar d and SD, I need to go to my calculator, stat edit, and I need to enter the data. Now, if you have extra columns, as I've said in the previous videos, arrow up, press clear, followed by enter. All right. So I've actually entered A into L1 and B into L2, but I'm really not interested in A and B. I'm not really interested in that information. I want to know what the difference is. So to do that, I'm going to subtract column 1 from column 2, or column 1 minus column 2. So second 1, that's the A column minus second 2. So we have L1 minus L2, and I should press enter, and it should populate. Now, I still don't have my X bar D and SD, but I can get to it very quickly from here. So X bar D, I'm going to go stat test and number 2. Make sure data is highlighted because this is a hypothesis test for paired. Now this only applies to paired, the mean will be 0. Our list of data is in L3. Make sure not equal is highlighted. And I get a lot of information, and I'm going to write down this information because I'm going to need it. But my X bar D is 0.29, and my SD is 0.6297. But I also got a T statistic of 1.4562, and I got a p-value of 0.1792. All right. So I'm going to plug in to my equation. I'm going to plug in X bar D, which is 0.29, minus my mu D. Then I have SD divided by the square root of n. Now, one thing that I'm missing here is this should have had a 2 times. This should have said 2 times that probability. And the reason is this was initially a not equal. This was initially a difference. And then we changed it to a greater than. Since we changed it from a not equal, we have to go 2 times the probability. So equals 2 times the probability that T is greater than 1.456 equals 0.1792 or 0.1793. So this is our p-value. They didn't give us an alpha, so we're going to use 5%. That's the golden rule if they don't give us an alpha. We're going to make these the same length. We have 1, 2, 3, 4, so 1, 2, 3, 4. And clearly, 1,793 is clearly larger than 500, so this would be a greater than. And when our p-value is greater, we fail to reject the null. Now, please remember, you have to say include either the HO or the null because I need to know what you're failing to reject. Are you failing to reject the alternative? Was it Valentine's and you failed to reject your lover? I don't know. You need to say we failed to reject the null. Tell me what you're failing to reject. So our p-value is 0.1793. We failed to reject the null. There is not sufficient evidence that alpha equal 0.05 to suggest the true population mean difference. So we need to have mean difference, make sure, and the reason that's there is because we're working with a paired test and detection methods for E. coli is different than 0. And when this phrase here is different than 0 ties directly back to our alternative hypothesis because it's a not equal, which is a different. So different than 0. So consequently, in simplified terms, we don't have any statistical difference between the two methods. All right. Either way, they have the yolk, E. coli, you're going to get sick. All right. So that closes out that video. And we will do, in the next video, we will do the confidence interval.